Why is Amazon paying me?
Check this out. I'm going to show you.
All right, welcome in everybody. Hope you're having a wonderful evening so far. Welcome in one, welcome all back to the stream. I hope you're having a great evening. Today is Tuesday, April 29th, 2025. Feeling good, feeling great. Ready to get back to the studying. Feeling good today. How are you guys doing? What's going on? We got the jazz going in the background. We got the smooth jazz. Jazz. You like jazz? All right, the plan for tonight, I think we're going to do elite code today. I'm feeling like we can solve elite code today. I don't remember clearing my cache or my history bit. Guess we did. Oh, come on. Huh. Let's go back. What happened to my account? Did I log in with GitHub previously? No. What? Hmm. All right, we're good. Hey, Ali Asgar, how's it going? How's it going? Welcome into the stream this evening. I appreciate you for joining me. Welcome back. How you doing? Or welcome in. I know I don't know how to do the CS:GO thing, and I can't download it because I don't have any more data. I uninstalled it because it wasn't compatible with whatever with a Mac. So that put a damper on that. All right, let's get into this. Oh boy. All right, let's wake up. Wake up. Okay. Is written in a zigzag pattern on a given number of rows like this. You may want to display the pattern in a fixed font for better legibility. And then read by line, PHN. Okay. Pal. What? The string PayPal is hiring is written in a zigzag pattern. On a given number of rows like this, you may want to display this pattern in a fixed font for legibility. And then read line by line as pan. Oh, applicig year. Okay. Write the code that will take the string and make this conversion given a number of rows. I don't get it though. What's the pattern here? Oh, it's zigzagging. It's like oh boy. Yeah, this problem is kind of silly. I don't really want to do this one. Like Tim was saying. Like what's going what's the point of that? Alright. Let's just go like what we normally do here. Where's our filters? Tenth line, rising temperature, isomorphic strings. Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if the characters in S can be replaced to get T. So two strings S and T are isomorphic if the characters in S can be replaced to get to T. So in this example, egg and add, the strings S and T can be made identical by mapping E to an A, mapping G to a D. Oh, okay, got you. So then, if you map, okay. False. Interesting. Hey, Dev God, how's it going? Appreciate you joining me on Twitch, dude. What's up, dude? Stop cherry picking. Ah. Okay. So we're given two strings, and that's all we're given is the two strings, and we need to check if they're isomorphic. So we say okay, if we go across the E, so let's pull out the old whiteboard here. Let's walk through this together, you guys. Have you guys solved this one? I think we can do this. So we have egg, right? And we have add. Okay. We're going to loop over our strings. So we're going to say, like, we need to loop over our strings, so we need to have a dictionary, right? Which is going to be our map. Okay. We're going to add characters to the map. As keys. And then we're going to assign values, right, of these other letters. But the thing is if you get that value, so if you come across it, so we're going to if this is in the map, so if S is in map, so we're going to have to loop over no matter what, S and T. So our time is going to be O of M plus N, or O of S plus T. So we have to check every character. Now, stuff will go pretty fast, though, on these checks because we're just going to be mapping. Okay. So let's think about this. So we want to loop over the egg. So we have a map. Letter map is equal to a blank dictionary, right? We say for so we'll say that n equals to length of S and m is equal to length of T, right? So for I in the range of n, so we're going to loop over I So the thing is how can we do this in a singular pass though, right? Can we do this in one for loop? That's what I'm trying to think about here. So if we loop over, so right now we have access to the length of the first, which in this case they are the same. Is that? So the length are equal to one another. Okay, so it doesn't really matter then. We're not checking for unequal lengths. That's a constraint. So we'll just say the length of n. So we'll say left is equal to okay, we'll say if s sub I in letter map, if it's in letter map, okay, so if it's not in the letter map, we're going to add s sub I into the letter map as a key. So letter map right, s index I plus equals to t index I, right? So we're going to assign the current character of s, the string s, so the e will go into our letter map as a key if it's not in there. And at the same time, we're going to assign the value of t as its value, the character of t at the same iteration space point as the value of the key of e, right? So e will have a value of a assigned to it. So if it is in the letter map, however, we're going to get the value so we assign it to our map. Elif, so if it is in our map, right? So it is in our map, meaning that we need to get the value. So we'll say mapped value is equal to letter map of s index I dot get, right? So we're going to get the value of this letter that is in our map, right? So if we come across E that's not in our map, so we assign E as a key and we assign A as the value of E. Next we move on to the G. That's not in our map, so we assign G as a key and assign D as the value of G. We then come across G, which is in our map, so we get the hashed or the mapped value, which is housed here as D, right? And we say if mapped value not equal to t at index I, right, we're going to return false. Else we're going to keep going. And at the end of this loop, if we don't return false, we're going to return true. Right? So let's think about this. We have for I in the range of n. N happens to be the length of our s character. Per our constraint, s string has an equal length of t string. Okay? So these will always have 3 and 3, or 5 and 5, or whatever. So we come across an E. Okay? So E is captured here. It's not in our letter map at the very start. So we add it to the letter map, giving the letter map E as our key, and we're adding plus equaling the letter map. No, we're not appending this, we're assigning the letter map to equal that value of T, right? We're not updating it. So we're assigning it to equal that value of t. So we're creating this, line item in our map. Okay, next, and then what we're going to do is we can either have an else statement or a continue. We'll just say else, I guess, and do that. Right, because if you don't have it, technically that is the letter that is assigned to that letter that is unique. And so if you get a letter that, we'll see, maybe there's an edge case or something I'm not thinking of Okay, let's keep thinking. So we come across the G next. That is not in our letter map. So we assign letter map with a key of G to equal a value of D. Okay. Else, okay, next we come across this G, another G. So that is in our letter map. So we're going to get the value of that mapped key. And then if the mapped value is not equal to our current iteration of this D, right? So it's going to get the value of G, which will be D per this previous iteration. And then it's going to compare it to this D in the T. And if that's not the case, then we return false. And then if we don't ever return false in this loop, we return true, saying that this is found. This is isomorphic. Oh, so I do need to say plus equal? I don't. Oh, yeah, I have to say plus equal to create it, not equal updates plus equal creates. Okay, I got it inversed. Maybe not. Shoot. What did I do here? Oh, do I need to... do this? Do I have to wrap this in a quote? I don't think I have to do that. So I got a key error letter map. Let's see. Do I have to give a quote? I forgot. Oh, I still get a key error. What did if an SIN, we add it in and set I thought we had to set the value equal to. Oh, we just set it equal. Oh gosh, I think. Stir object has no value get. Stir object has no value get. We don't get stir object has no value, has no attribute get. So this is giving me a stir object back. Oh, this is giving me the this is giving me the value of it. Anyways, I don't need to get. Ah, there we go. Bada bing, bada boom. Mr. Worldwide just stepping there. No. Oh, bummer. So close. So BADC and BA. So B gets mapped to B, A gets mapped to A, D gets mapped to B, C. So the B gets mapped to B, the A gets mapped to A, so the B got mapped to B, the A got mapped to A, and the D got mapped to B. So we have two mappings to B. And then the C got mapped to A. So we have two mappings for A and two mappings for C, or two mappings for B. So then if we map a the value. So I need to check if the mapped value is in, right? No. If map value not equal to this, return false. Or if map value is in the letter map, we'll return false, saying that we've already mapped. No, I guess maybe not in letter map here. So we map it if it's not in there. So in the case here, we have B. We mapped it to B. We come across A. We map it to A. We come across D. This is not in our letter map. So if we say if S index I in letter map dot values, we're going to return false, right? So if it's not a key, we're going to check if it's any of the values. It's already been mapped as a value. If it's already been mapped as a value, so we come across the D, this maps to B. If the map value, okay, so no, we have that. So if the mapped value, right, so we map B to D here, but if the mapped value is in the mappings or mapped value in letter map dot values, we return false. Come on. Sorry, mapped val. Come on, show me the money. No. Ugh, really? Trolling. So if we map the D to a B, but the B has already been mapped to the first iteration. So if they come across B. Yeah, so it's B to B, but so if map value not equal to T, or map value in letter map dot values, this letter map dot values will give me all of these previous values. So if B is in letter map dot values, it'll return. So why is this one still giving me true? I'm going into, so in this case, let's roll it. So I'm going over the B. It's not in the letter map, so I'm mapping B to B. A is not in the letter map, so I'm mapping. D is not in the letter map, so I'm mapping. Okay, so then we need to say we map. So we say we map the here to here. So, but we need to say if at this case. So if T index I in letter map dot values return false, right? And then we'll remove this here. So we need to check if the B that we're currently trying to map to D, right, it return false, else letter map is here. Bada bing, bada boom. Yes! Ha ha ha! Woo! Right, so we just had to check to make sure that the letter we were trying to map first before we do the mapping is in the letter map values. If it is, then it's already been mapped to a previous letter and we need to return false. So I could probably clean this up with some logic, right, to remove this double if. So let's say if it's in the letter map, so if it's not in letter map, so if it's in letter map, so say if S index I in letter map, right, we're going to get the mapped value of it. So let's take this here. Like so, right? Else it's not in the map, so we can get rid of that. Do here, like this. And add it to the letter map and return true. I mean, that still has the nested ifs up front. If in letter map, if the map value oh, whatever. I'm going back. I broke it. I'm going back. Yeah. All right, cool. That was 205 isomorphic strings. Very nice, very nice. Not bad. Not too bad. Solved that one in under a half hour. Sweet. Let's take a peek if there's anyone we want to do here. It's not too bad. Contains duplicate 2. Given an integer array of numbers and an integer k, return true if there are 2 distinct indices j and k in the array such that numbers I equals to numbers j and absolute value. What? Absolute value of I minus j is less than or equal to k. And an integer k, so k is 3. This returns true. One and 1 are the duplicates. 1 minus 1 is 0, which is less than or equal to k. So in this one, can we do a similar thing and do another hash map, or like another map? Find all the counts of all the values for the ones that are greater than 1. We'll do this logic check, and if any of those are true, then we'll output true. But is there any way we can do it while we're checking over the current loop rather than having to check all the values in the map? So if we add it while we're going and then do the logic check. But absolute value of I minus j. So you have to know the indexes as you're going, right? So n is equal to the length of nums. Say scene is equal to a set. Or no, wait. You gotta give it a map because you gotta give it its index, right? Right. And then we'll give it a tuple of all the indexes, right? So we'll say for I in the range of n, right? If nums at index I not in scene, we're going to append it to scene by calling the key of nums index I, and we're setting that equal to a tuple of I, right? So we'll set that equal to a tuple of I, okay? So then or maybe we'll set, we could do a list. I mean, but they're all gonna be unique, so it's whatever. So if we set it equal to a list and put in I here, right? So if it's not in, we'll put it there. So if it is in, right? So if it is in the map, we'll get the scene indexes is equal to scene at nums index of I. Right, so that'll give us this list back of all the indexes. And we say for well, we don't need to. If it's not in, we add it. If it is in, we're going to get all the scene indexes before we add in the parental. Okay, yeah. So for so is there, so if k is 3, whatever. So for index in scene indexes, if the absolute value of I less the index is greater than or equal to k, return true. If it's not, we're going to keep going. And that's it. And then if we don't find any, we're going to keep going. We're going to assign scene nums index I dot append I. Okay, so for I in the range of n, if this, so we're going to say, is this in our scene? No, it's not. So we're going to add it in. So 1's in our scene with a list of all the indexes. So we have 0. So 1 gets saved as the key, and I, which is 0, gets saved as a list and the index inside of it. So 2 then gets saved as a key with the index of 1 as its list. 3 gets saved as a key with the index 1 as its list. And now we come across to 1, which is in our nums, which is in our scene. So we're going to get hit with this else statement. We say scene indexes. We're going to grab all the indexes of the current value of that one, right? So for index and indexes, if the absolute value of that index we return true, we evaluate the current index against I, or sorry, the index of all the scene indexes against I via this formula here, and return true if that is true. So we will return so it's the if this I don't know, whatever, hold on. So if return, then we add the index on if it's this is false for all of the cases. We add it on and then keep going, and at the end of this loop we say return false. First try. But it's slow. It's slow. It is slow. Anybody have some optimizations? So if we use a set, rather, you mean for here or for here? So if you use a set, I want to get back to the index. Where do you see? Bum, bum. Let's see. I don't want to look at the code. I want to coach through it. All right, let's go here. Let's take this. Let's go. I am working on Leet code 219 and got a correct solution, but it's a little slow. Can we walk through refactoring my current solution to a more a better one? Don't show me code. Use my current understanding, and let's go step by step. Alrighty. Keeping indices per number, that gives us a solid base of work to form. Let's begin by identifying where the inefficiencies lie. You're storing all the previous indices of a number. Then, every time you see a duplicate, you're looping through all of those indices to check the difference. If we only care about whether the two numbers appear within the k indices, if we only care about whether two same numbers appear within k indices of each other, Oh, okay, so that's what that means. That's okay. So the k basically says, is there a duplicate that appears k spaces away, basically, right? So if we're on the one here, is there a duplicate that appears 3 spaces away? 1, 2, 3. Yes, there is. That is true. Okay. Oh, interesting. So the k value really means, is there a dupe that is within 3 value, or within k values from here? That's the key insight. That problem only cares about whether any duplicate exists within a distance of k, right? Not about all distances or all occurrences. So now consider this. We've already checked that a previous duplicate was not too far away, more than k apart. Do we need to keep it in memory? No. Or put it differently, could we just store the most recent index of each number instead of all previous ones? How would that change your approach? You would be just assigning I, not list I, to the key. Instead of doing a scene nums index I, if we just do a singular I, where that would be seen. Now let's think one step further. So else scene index is equal to this. Oh, you would have to just check if it's less than k. Right. So So you would only then need to check that scene. Okay, so the scene index, if absolute value of I less scene, right, index is less than or equal to k, return true. And instead we'll go scene nums index I becomes equal to I here. Aha! Let's go! Back again! Back again! They call me Mr. Two-Time! Mr. Two-Time! Boom! Haha! We were able to come to that one ourselves here. I wasn't done solving it, Mahan. I wanted to optimize it. Now I'll look at other people's solutions. So you did a set. You have the range of the length of numbers. If it's not, you add it to the set. You return true. If the length of the set is greater than k, you remove the numbers at that point and then return false. Oh. Interesting. You remove the index. Okay, so you remove that previous index then. You solving for the j index and removing it. And then update, because you're automatically adding I up front. Oh, if it's in there, return true right off the jump. Interesting. Interesting. Nice, Norpie. Great minds think alike. Now, if we can combine the two together, mega algorithm. All right, that was sweet. That was number 219. All right, so I want to push it further and explore a sliding window set version. Yeah, so I was thinking about that too, right? If we're only searching for k values, can we not sliding window this, right? I am pretty bad at the sliding window, but let's give it a go. Lol. All right. Think of a sliding window as a set of the last k elements we've seen, not their indices, just the values, right? The idea is, as you move through the list, your window contains at most k elements. So at most, we're going to have 3 elements in this window. Right, because at the start we have 1, we have 2, we have 3, and now that we have 3, we move on. If that is in the sliding window, we remove the place of it from the sliding. Okay. So can we go like this? So I in the range of n. Oh. As you move through the list, your window contains at most k elements. If you see a number that's already in the window, that means it's a true duplicate. It's a duplicate within the last case step, so you return true. So how do you keep track of the window then? Is it a slice? So if not, you add it to the window. If the window gets bigger than k, you remove the oldest value. If you start at index I and move our set, and our set is keeping track of the last k numbers, how do we know which numbers to remove from the set when the window is too big? The length of the set. Okay, so we're going to use a set then. So window is going to equal our set. Okay, and m is going to equal the length of we're at index I, and our set is keeping track of our last k numbers. How do we know which numbers to remove from the set when the window is too big? This would be it's kind of similar to what NordPy did, right? You do the absolute value of, or you would do I minus k be equal to j. Negative j, I minus k, gives you the index of the number that just fell out of the window. That's the one you write to remove. Yeah, similar to what NordPy did. Here's the loop logic in words. At each index I, okay, so we'll say if the nums at index I in window, we're going to return true, right? Else, it's not in the window. So we're going to go window.add nums index I if length of window greater than k, window.remove I less than k, absolute value I less than k. And then if the set is more than k, else remove I less than k from it. That is the oldest or lowest index. Yeah, exactly. It's lingering, still lingering in the window. Okay, well, the sliding window is pretty easy then. I just never really gave it a good thinking. So if it's in the window, we return true. We add it to the window. If the length of the window is greater than k, we remove this. And if we get through this, we return false. Key error 0. Window dot remove Allison value. Well, if I is 1, 0. If I is like 2, case 3, 1. And adding window slide by removing the earliest elements. If the length of window is greater than k, we remove I less than k. It's not the absolute value. So then, yeah, I guess this is probably the exact same one as yours, NordPy. You just used a set rather than use the window, and I just kept indice values in. Interesting. Okay, interesting. I just never really have done the sliding window before. Okay, so then we remove I less than k. So if I is 2 and k, well, if it's in there, if it's not in there, well, it can't be greater than k, so this wouldn't happen. Because I would be greater than k at this point in time, because you would get more than k elements. Ah, okay. You return false there. Ah! Still key error 0. The window slides by moving the launch can, and then you just on A. At any step, I don't know what's worse. It's in English. So if I do window dot remove I less than k, that gives me I can't index into the set. You remove that value from window. So we add it right in. If you grow greater than k at that point in time, you remove the least most. So I less than k. Okay, so then should I instead add? Okay, so we need to add the element up front, right? We need to add it up front if it's in there. No, we don't want to add it up front because then it'll be in there. So we have the add here. This will add in the 1. The length of the 1 is that one, so it won't remove anything. So then the length, so I is 3 here. Less than 3 will remove the 0. So we're adding the number. Okay, so this is the index to remove. Right, not the actual number to remove. We need to remove at I minus k, not I minus k. So then how can you specify it in a set? I thought you can't index into a set for a specific value. Right, so it's trying to remove at I minus k, whereas we're adding actually the number in. And that's what we're checking if that's in the window. So should we instead do, if the index is in the window, we're going to return true. No, because there's no duplicate indexes. So you have to return true on a duplicate number after you add it in. If the length of the window is greater than k, we're going to remove not, this is the index we need to remove from the window, but we can't remove from sets a specific index like a pop. So if we need to get a value, well, we have reference. The only place that value is located is in our set from this add here. But then we can reference the value that was added at that current iteration by saying every num's index I minus k, right, is the oldest number here. So this would have to be num's index I minus k to, instead of accessing the index I minus k and trying to remove 0, we're accessing num's at 0, which is 1. And so now we're putting 1 into the value to remove for the window. And so now I think we'll get it. Aha! That one was slower than my previous one? Dang. Boom! O of n, O of k space. Oh, that's all edge cases. So what was my previous one was O of... whatever. All right. Sweet, we got that one, guys. Leave a like for that one. We really we gave that one a thorough working. We got a couple of solutions on that one. This one was my first that wasn't very good, right? And then we optimized it further and got an even better one, my fastest one here. And then we optimized it even more. This one has better memory, but slower. This one is faster, but worse memory. Interesting. All right. Hey, Robert, Johnny, what's going on? Dude, I don't know how to solve 48. I don't know how to do it. We've looked at it like twice. Where is it at? You're giving him an n by n 2D matrix representing an image, rotating the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the 2D input matrix directly. Do not allocate another 2D matrix. I don't know how to do this one. What do you mean? We worked on it for like an hour last time. So if we're given 1, 2, 3, 4, 5, 6, 7, 8, 9, we're rotating the row as the column. Every row becomes a column, and every column becomes a row around our centerpiece. Except for when we go to 5 by 5, these inner ones, right? These inner rows become inner columns. So that's the only current way I have thought about solving, is that you make rows basically become columns. So your 0 row becomes your last value in every column, your negative value. Whoops, don't want to have that open. So let's think about it. So if we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this would be 0, 0. This is 0, 1. This is 0, 2. This is 1, 0, 2, 0. Or is it 0? I forget. What is the n? Is it column by row or row by column? This would be 1, 1. This would be 1, 2. 2, 1. 2, 2. So the 0, 0 becomes 0, 2. The 0, 2 becomes 2, 2. The 2, 2 becomes 2, 0. Five hot Y is very. Oda, you're funny, dude. So we need to take our first value and make it the last value of a list. This. For I in the range of J is equal to, we're gonna loop over every list. I is every list, J is every sub number. So first list, first list, first number. Becomes, the thing is you can't build a new matrix. You have to modify the 2D input matrix directly. So if you take the 1, you need to like swap values. Here. The 2 goes. Oh, they have a typo right here. No, they don't. I'm tripping. Here. 13 and 15. Oh, you just grab. Oh, you grab every value and build an array backwards. So you grab the 5. So you grab the 1, you put it here. You grab the 4, you put it there. So the 1 goes here. And then you take the 3 and put it here. And you take the 9 and put it here. And you take the 7, put it here. And now you're back at the start of where you were. So now you move forward. The 2 gets picked up and goes here. The 6 gets picked up and goes here. The 8 gets picked up and goes here. The 4 gets picked up and goes back to the 2 spot. And the 3 gets picked up, goes to here. The 9 gets picked up, goes to here. The 7 gets picked up, goes to here, and we're done. So 1 goes to the 3 spot. 2 goes there, 3 goes there. I swap I and J. I's gotta go 2. So J's gotta start at the back. I starts at 0, J starts at 2. We swap, move J down. J now becomes onto here. J stays at 2. So J stays at 2. Because we need all of these values to come over here. So if J stays at 2 and we swap 0, 0 with 0, 2, that moves the 3 and the 1 over. J stays at 2, I goes up. Now we're here, 6, 2, and then we move J down, and then I resets. Alright, so let's think here. Alright, so we say so n is equal to the length of the matrix for I in the range of n we'll say while we'll say we say J equals to n minus 1. Right? J will equal n minus 1. We say for in the range n. So I want to make I 0, 0 and 0, 2 swap places. So if I say left is equal to n, or matrix at index I so if the left is equal to matrix index I 0, which it'll start, so then, but j is not 0. J is starting at 2. It's gonna go 0, 0. Then I'll go to 1, 1, 2, 2. I don't want that. I want 0, 0, 0, 1, 0, 2. And then this and that. So I be 0, 0, but we don't have j established yet, but I don't want to put in a 0. So if I say 0, 0, copy is equal to n. If we establish j is equal to n minus 1. So if I access left is equal to I 0, this is going to be right. So my right is I index j. So this would be the 3 here. So 0 and 2, which will be the 3. 0 and 2. Which is my right variable, which is what I want to move to here. So maybe this is my left variable to start. So then this, what is this one? This one is, where's my, come on, pull up my whiteboard. What's over here? So 2, 2. So 0, 2. I 0. So hold on, let's go. Our left is going to equal to matrix at index I, so 0, index of, so let's first establish that j is equal to n minus 1. And if I do j minus n, if I do j minus n, then j minus I. So the left will be index I, j minus I. So this will be the 3 at the start, because j will be 2, I is 0, so this is 3. So then the right is equal to matrix index j. So this would be 2, j, j, 2, 2. So j minus I. So it'll be j minus I here. So matrix of index I is 0. So the 3, and then the right is j minus 1. So 0, or j minus 1, which is 2, and j, which is 2. So then we say we need to set these equal to one another to swap them. Right? And then we need to do a loop over j here, right? So j needs to n minus 1. So j equals to n minus 1. So it would be a 2 value. We want j to then go down to 1 and 0 while I increases from 0 to 1 to 2. So I guess we'll say for j in range, we want to go from start at 0 to with a negative 1 step. I always forget how to go backwards. It's always like it's like a thing I can never remember for the start and stop conditions. They always confuse me. So let me go to my Nico practice here. And which one is this? This is 48. How about my tunes? Where are my jazz? What happened to my jazz? Oh, go back. All right. You like jazz? All right, so then let's say for j range 0 to 2, then negative 1, print j. What is this print? start at 2, go to negative. Okay. So start at 2, go to -1, not included with the -1 step. Okay, so we swap those values. Right, so 0, 0 becomes 0, so I'll stay. So 0, 1 becomes 0, 1 and 2, so the 3 becomes 2 and 2 here, and then 9 becomes here, so those two values are swapping. Now j goes down, I stays, so this value, and now j is 1, 2, 6, these two are swapping, now these two are swapping. And then I increases to the next list, or row. J, so we don't want J to go over to these values at 2 then, right? We don't want J to be, because the 4 needs to swap with the 2. Because after this loop, then I becomes 1, so boom, J is 2 at this 6. We don't want that, because we've already done something with that value. We've moved the 2 value there. Now the 2 values here. We move the 2 value to here. I use VS Code currently. Harass Gojeb. Welcome. This will be n minus I. So this will be 2, and then it'll be so actually n minus 1 minus I, so 2 minus 0, 2 minus 1, 2 minus 2. But I need it to run 3 times to swap all 3 values, so all 3 of those swap with all 3 of those, which swap with all 3 of those, which swap with all 3 of those. All 4 of those swap with all 4 of those, all 4 of those. Yeah, I don't think it's gonna work. Yeah, I don't want to do this. I want to work on a project. Alright. Yeah, that problem sucks. Alright, so back onto our TLC project here. I made some changes to the plots here I wanted to show you guys. So this is our TLC chromatography plot. I made some updates to the functionality or the actual visualization of this. And as you can see, it's kind of now has this kind of grouping going on as it's traveling up the scale here. And then it freezes at the end with the remaining compounds. So it does. So the thing is it has a little bit of a jagged start though for some reason. Not sure why. Yes, there's a lot of biochemistry like enzymes and a lot of stuff like that that is used in organic chemistry. Alcohols, functional groups, stuff like that. So now it kind of mimics like the actual plating as this compound goes in. Now, I'm not really sure if I like this solvent kind of being also treated as that grouping and then just coming up, but you know, that is what it is. So technically, but the solvent is more of like a hard line that you can see of like everything is kind of saturated in the solvent. Like it would be kind of like a shadow almost. So it's kind of interesting. But I don't know why this reconfiguration is causing this like initial delay right there. Why is it like pretty delayed? So I'll show you what I did here. So what I did was I lowered our initial frame count to only render 100 frames, right? And then what I did was in our function here for computing these, as first I added this part right here. So I went and after I computed all of the X data and Y data, right, this is going to generate all the X data and Y data for a compound given a retention factor and a quantity, right? It also computes those buffers, basically like the X like sway of the randomization. So what I'm doing is I'm grabbing the last value of both X and Y, so the last data point at which it finalizes at. I then am creating a buffer, right, which is a list of that data point multiplied by, you know, a factor of 0.25 or floor division or like integer division of 25% about of the total data quantity. So the data quantity is the frame count, right, which is 100. And so I'm passing, so that means that I'll render out 25 buffer end frames, which will mimic the final values of the graph. So that's how I'm getting that to kind of stall at the very end when I reach 100%. When I reach 100%, it stalls out there and shows just that final point value for, you know, a few times. Now I don't want to look at the solution. Please don't put the solution. Where did you put it? Right, so when you get up to the top here, it'll stall out and show that final point value, like mimicking what you would see at the end of your plating right there, like that, right? Boom. So that's how that is taking place. And then, so right now I'm just printing that data. So I'm going to just remove that so I'm not doing that print. But I don't know why I'm having this jagged start. Like it starts pretty jagged. So let me go actually up to my prints here and see where my starting point is. I'm starting at zeros for the lots. This is my RF factor. Right, my RF factor goes up. So my solvent starts at 0 on the X, and then its Y values go up by 1, all the way up to 100. Or up to 99, and stall out. Right. this one starts at, like, has these randomized, it's a little bit random, right? But it stays consistent around 1 plus or minus some percentage of buffer. Whereas it increases starting at 0, 0.6, 0.1.3, 2, 2. So it is starting from 0 and slowly going. So the thing is it's, so what I did in order to get that visualization for the groupings going up rather than the whole trail being shown is that I did this here. So I'm taking a slice of the current frame less 10 frames up to the current frame. So I'm generating, 11 frames of spheres per compound in this grouping. But it kind of starts out pretty funky. So it's interesting. I don't know why it's kind of starting off a little bit fun, like choppy, basically. Like it kind of jumps here. Boom. Hello, Malanetta. Malanetta. Sorry if I pronounced that wrong. Honestly, just hours and hours of just practicing and just messing around, trying different stuff, failing over and over and over again, doing courses, reading books. All of it has just added up, and getting practice with loops is really, really probably one of the biggest things, is understanding loops through and through. And indexing is another huge thing. So loops and indexing is probably one of the two biggest things. And then object-oriented programming. And then like obviously functions and stuff. But Malone, Malone. Hey Malone. Thanks for coming in. So right now we're rendering out the frames for. We're generating data plot objects for I and key. Right, so we'll say if key so plot objects out of pen x plot. So my compounds. So if key is equal to solvent, what we'll do is we'll plot objects. We'll do this. At that key, we'll render out the entirety of its frame to show else do this one and do less than 10. So the solvent will now climb up higher. Right, there you go. So now the solvent is climbing the entirety of our x-axis, our y-axis, whereas our compounds are drifting upwards here. Hmm. Yeah, that looks cool. Mike, when are we launching ChemHub? We gotta build it. I don't know. Should we build like a full-on chemistry site? I don't know, dude. I suck at web dev. Like it's just really terrible. Like this fast API stuff is just taking me forever to figure out and get around. It's such a learning curve. Anybody want to be like, woo, hiccups. Anybody want to be lucky number 1890? We're looking for sub count 1890. 1890 going out there. 1890 going out there once, going out there twice. 1890 going out there. Thank you guys for being here. Hey, there it is. Hey, Emma, how's it going, Emarita? Amartia. Sorry. Amartia. All right, so this is our thin layer chromatography simulator where you have a solvent that drags compounds up off of the x-axis and according to a certain retention factor. And as you can see, these compounds start to drift upwards, and this purple compound does not move at all. It has a really low retention factor, whereas the retention factor for these other ones are fairly high, and so it goes up, in correlation with the solvent. A chem sites call it Rapula, then GitHub probably don't ever download. Well, Tim, we made this. We made this. Were you here for this? So we made this. We have this so far. So what right now you have the ability per our chroma plot. This is this is my unrefactored. This is my script for generating the plots that I refactored into the chroma plot class for creating plot objects. But I have to reconfigure the plot objects to align with my new configuration of these. How I'm like this was the trails as it was before. But you can put in various, compound names, and then RF values, and then you can run the simulation. It'll load for a second. It's not super fast. It's really not that fast. And then you get this. So I currently have it to where we're able to receive user data and generate graphs just in new tabs here, right? Hey, for those that are new, thank you guys so much for being here. My name is Mike. I'm 26 years old. I got a degree in human biology and a minor in chemistry, and I'm making a thin layer chromatography project in Python right now, Python and front end and stuff, I guess. But yeah, see, it goes up and then it resets there. So this doesn't have the current functionality of our previous run here. So let me go ahead and actually go to our plots here. What happens if I make this frame count 200? And I run plots pi here. It still does this jump. still like not that smooth at the start. Like it's still, this one goes pretty smooth, but then it lags for some reason. I don't know why it lags. Right at the very beginning it goes, and then these other ones. Oh, because there's a retention factor. No, duh. Right? It's not going to apply until this one goes up. These are at 0, 0. But it's not showing the dots at the very beginning. Why isn't it showing? It's not showing 0, 0, I guess. So maybe I should start at 0, 1. Because these ones... Sorry, Odinson, I don't have any stream bots, so those commands aren't gonna work, dude. But this is a noob stream over here. Bootleg stream. Hey man, how's it going? Himanshu, welcome. How's it going? CJZ Plays, how are you actually determining the trace it leaves behind? Do you have a formula? Yeah. So I generated this algorithm to figure this out. It's nothing too crazy. So what I do is, well, this is my new revision, right? To represent, this is what you'll actually kind of see in the lab, is you'll see these kind of groupings drifting upwards, right? Kind of looking like smears, but they don't leave behind like a trail. Sometimes they do, like maybe leave behind like a smear, but nothing like what I was displaying before, like a solid trail. So like what it's doing is now it's just creating like a grouping of 10 and going forward from there. Now what I'm doing is, as I'm not rendering out 10 random frames each time, I'm just using the 10 previous frames along with the 11th frame on top to render out the climb, like kind of animation. So it's not 10 random points each time, instead it's the it's the 10 previous plus the new one on top. So that's how I'm doing that is, I'll kind of go through my algorithm or my functions here. So all this is doing, this kind of looked kind of crazy, but all this is doing is just generating 6 compounds, right? With the first compound being a solvent, and then 5 random compounds from there, being comp 1 through 5, starting at x equals 0, going through 5, y starts at 0 for all of them, and the retention factor is the random number between 1 and 0. So that's how I'm generating the compounds. Now I wrote this compound class to, house these compound containers for me, right? I'm really big on creating classes. I make classes pretty much for everything. So then what I do is I specifically get the compounds in a certain format. So I have a compounds list here, so I'm just putting them all into a list of their objects, compounds, right? But then I'm now converting them into a specific format where I have the name as the key of this dictionary and the value as the compounds get data method. Now the compounds get data method is just getting a list of the of the values for every key in the self.dict.items, right? So I'm just getting a list of all the values. Now I did this because I don't want to actually get the name. This get data just gives me the x, the y, and the retention factor in a list of this compound, right? I have get all, which gives me everything, but get data just gives you the data, and then get coordinates just gives you the coordinates. Now I could have a get rf, which will just give you back to rf, but you can just get that by calling self.rf. So that's what that's doing. So I'm just formatting it into the specific format, right? So then what I'm doing is I'm going to create a dictionary called X data and Y data. Now, there's a lot of like data stuff going on, just bear with me here. Is the X data dict and the Y data dict is going to contain, right? It's going to have a very similar makeup to our compounds, but the key is going to be the compound name, but the value is going to be a list of all of its X data and Y data, right? So what we're going to do is for compound solvent, we're going to get all of the X data and Y data from the solvent compound for 200 frames, right? So we're going to generate 200 data points for starting from nothing going up to something. Now, whatever that factor is, we have to determine, like, how are we going to increase our data? We're doing that in this generate data function. We'll get there, but what we're doing is we're creating a dictionary, X data and Y data, where every line item or row in the dictionary will be one of our compounds, and then the values will be all of the 200 values of X data and 200 values of Y data for those compounds in each of these, right? So you'll have solvent, all of solvent's X data in here, and all of solvent's Y data in here. All of compound 1's X data and all of compound 1's Y data in here. 200 data points each for every compound, right? Or whatever this variable contains. And so then what we're doing is, don't worry about this. This is just creating the actual plot itself and making the animation. So, you know, I can go over this in a second, but the generate data function, what we're doing on the actual, to generate these 200 data points, is we are saying, okay, if, just to have some clarity, if the user does provide a compound, right, if the compound has value in this list, right, remember the compound is, we're providing the compound of compound key, which compounds is just this is a get data list, right? So we're providing the key of the compound, which is just compound name, and the value that's being put in here is this get data list. So this list is being housed here, which matches our type hints here. The data quantity, I'm just passing in the frame count for the amount of data I want, so 200. And then in this first instance, and then I have solvent, like a flag of being false by default. So if compound, so if there's data in this list to generate, right, we're going to create X data and Y data. So this is all the X data and the Y data that we're going to pass back to these values, right here. So we're going to loop over the data quantity. So we're going to do this 200 times. Do something 200 times. Now what are we going to do? Well, okay, if not solvent, meaning that the solvent is false, which in this case by default it is, so if not solvent, we're going to create an X buffer. Now what I mean by this might be kind of hard to follow, but if you just just bear with me here, is I wanted to create, rather than having every element on the X-axis stay at its 1 and then go straight up on the Y, right? That's how it was before. It was just a straight vertical line at the X-axis starting at 1, 2, 3, 4, and 5 going straight up. Now instead of it going straight up, liquids are kind of variable, right, when they're passing through medium. So what I did was I added in this buffer of a little bit of X kind of sway left and right, a very small little sway to kind of mimic it traveling upwards through the medium with a little bit of kind of movement to it, like a little bit of jitter, you know? So how I did that is I created a factor of this, right? So I wanted to do about 5% or 0.05 of the current compound, right? So the current compound, value, I'm taking the square root of that and then adding a small figure so it's just not 0, right? So in case like it's you don't want to take a square root and have it be a 0, right? You don't want that. So it doesn't overlap the solvent or whatever. Or you can't divide by 0, I'm sorry. That's why we're doing this. But we take the square root, and now why are we taking the square root of the compound index 0, which it will be that what we're doing 200 times, so we're taking the X value of the compound and we're multiplying or dividing it by this buffer. Now, I feel like I'm doing a pretty bad job of explaining that. Just subbed at 3 turns to a 4. Hey, thanks, dude. Appreciate your shot, Blake. Pretty cool, huh? So, we're taking the square root because think about it. If we have a buffer that starts on X equals 5, or a compound that starts on X equals 5, so if we have our table here, or our graph, right? If you have ticks here, and you have a compound that starts over here, well, 5, if you take 10% of 5, it's going to be a little bit wider than 10% of 1, right? 10% of 1 is going to be bound by like this in blue, whereas 10% of 5 will be bound by this in blue, right, for the 5. So just kind of by scale, that's how like the scale works. So what I did is I divided by the square root in order to kind of factor this down. So square root of 5, right? So now this makes this go even smaller. So when you take the square root of 1, well, that really doesn't go too much smaller, whereas this will make it so that now everything kind of has a little bit more uniformity in terms of their constraints versus how much these compounds can jiggle left and right. And as you can see here, I'll try to show you guys, they're jiggling left and right. You can see the new value is kind of being randomized in between some range here. And the red one, you know, it does show that this one's a little bit more spread out than the blue one, just based off of the math alone. Now I can probably tweak this maybe a little bit more to kind of use I a little bit better as it increases, right? So maybe we could reduce by a factor of I even more so that we could tighten up these later values or later kind of cell chunks. So we could reduce the sway variability or percent buffer that is allowed to move left to right. Does that make sense, you guys? So that's what I'm doing there. And so then all I'm doing is then just taking the low and the high by taking the compound the x minus what I made right here, the compound x plus what I made right here to give me the low and the high, and then I'm giving you a random value between those two lows and highs. So that's how I'm creating that. That's my low and high, and I'm getting a value in between the low and the high. So that's how I'm creating that jiggle. And so then I'm appending it into the buffer itself. So then if it is the solvent, right, the solvent doesn't have this jiggle. I don't want to have this jiggle effect on the solvent because, as you guys know, the solvent is just traveling up that y-axis just to kind of show the 100% speed as these lag behind by certain randomized factors. Now all this looks pretty uniform. It's actually going pretty close. So all these kind of by luck random out to be almost pretty similar. And so, right, we append, and so we just append 0 and 1 for the x and y data for all of these. Now, what I can do potentially, or we'll come back to that later. So then all I'm doing is I'm just updating the compound, right, for the next iteration. In the next iteration, the x value stays the same as the one that I computed from the previous, right? I don't want to, so before actually I was putting in the randomized value here of this buffer, x buffer, and I'll show you what happens here. It's actually pretty interesting. You get some pretty cool effects. So if I put the x buffer in as the value that I'm going to recompute the new random value on top of, so think about it, random value being computed, put in as the x, then random value being computed on top of that random value. So instead of computing back on the baseline x equals 1 or x equals 2 or x equals 5 every single time, I'm computing off of a new randomization. So you'll see that it gets some pretty weird effects. Buffer, x buffer. What? Associated with a value. Oh, because it's only found in here. What I'll do is this then. I'll go here. Right. So this is what happens. You can see that it'll start to kind of take its own shape here. You'll see that it'll start to kind of really move. Like this yellow is starting to really go right. This green is starting to really go right. But it's really, it's random, right? It's computing random values off random values. So instead of growing up, you have more variability to the left and right. So then, right, and then I already talked about it earlier, but all I'm doing is at the very end, I'm just getting reference of that last point wherever I finalized at the very top for each compound. And then I'm just freezing it there for an additional 25% of my frame count. So I'm just going to freeze it at the top so you can kind of mimic what it would look like as it's finalized. Because when the in the lab, in the thin layer chromatography, when you're done, it's just a singular kind of dot at the final value whenever you took it or removed it from the solvent or the mobile phase, right? So then it becomes the stationary phase where then you can compute a RF value by taking the current value of the solvent divided by, or the current value of the of your compound divided by the travel distance of the solvent via the y-axis, and then times that by 100. That gives you your percent, or you can leave it as a decimal to give you your decimal retention factor. So we are just pre-computing those factors in order to show this travel ahead of time, rather than doing it the inverse way and experimenting and then solving the retention factors based off of unknown. So that's that right here. Hey, anybody want to be lucky number 1900? We got to get ready, our phone ready for a screenshot on the channel here. 1899. I got to get ready for the anybody want to be lucky number 1900? There she blows. Thank you guys so much for the support day in and day out. Trust me, you guys. I truly am so thankful for you guys hanging out with me every single day as I learn and teach myself, Python, computer science, and programming. I read books, advanced textbooks. I watch lectures. I take courses. I teach myself. I try my best to do the right methods and learn everything the right way. And then, just do it through a transparency online with you guys here. So thank you guys so much for joining me day in and day out. We went back down. No! Oh, one of you guys are trolling me. But so what we're gonna do is I want to every time we get 100 subs, or every 50 subs, we'll open 1 or 2 CS2 cases. But I currently I can't download CS2 or play CS2 on Mac, so I don't know what to do. Hey, we're back up to 1900. Feels like New Year's Eve. Must be how they felt in New Year's. For the buffer, instead of calculating a random variation based off the index of the compound, why not generate a random value for between 0.5 and negative 0.5 and then add that to the index? Yeah, that's a good idea too. That's a good idea, Bailey. So he's saying to, instead of computing a buffer factor that is 5% within the, or 5% of the square root of the index, or of the x value index, right? Instead of doing that, why don't I just do a buffer factor of a fixed less than a value of 0.05. That's a good idea too. So let's try it. So if we do a buffer factor of so if we take, so rather than computing even a buffer factor, you just do a compound less a fixed rate here, right? So we'll keep the buffer factor variable, and we'll put in a value here of 0.05 here. And so then if we do this minus just the buffer factor, or just plus the buffer factor, now instead of computing based off of square roots, now you just have a fixed value of where it'll stay. Now everything's grouped. That's a great idea, Bailey. Thanks for that input. That fixed our, that completely solved our thing. So now these are much more tightly compact, and they're uniformly compact across all indexes of our graph here. So now there's no more, extra little sway as you increase. Was that what you meant by that, Bailey? I think that's what you meant. What's up, IMAX? How's it going? I appreciate you for joining me here. Thank you so much for coming in. Miss Gina. How's it going? Stephen Talik. I'm just starting my learning of Python. I have a long way to go. Yeah, me too, dude. Man, we just hit 1900. We're already at 1904. You guys are killing it. Hearts in chat for you guys. You guys are awesome. Hey, Austin. Is ChatGPT down? Hello. No. It's good for me. Okay, so let's go ahead now. And then let's repopulate our... So right now we have plots.py. And then we have our chroma plot. So the only difference is that right now this has our refactored or new approach at displaying these, and we just need to transfer this now over to here. So this stays the same. All of this stays the same. Yeah, all this stays the same. For the generate frames. So here on the update function, this changes. So this is, oh shoot. Self.formatted compounds. Right. If key equals plot objects. So let me say self dot. I'm messing with this jazz. You guys like the jazz? It's pretty soothing. I'm a big fan of jazz. I love jazz. I don't really know a lot of like jazz like in depth, but I do listen to a lot of jazz. So then I created this total frames here, right, which is my frame count. And we put in we put in total frames here. Right. Let's move that. So then in my generate data now, I created this buffer factor, and then I lessened by the buffer factor, like Bailey suggested. Big ups, Mr. Bailey. Pin the buffer factor, comma 1, 0. And then I added this here to allow for the freeze. Right. Okay, so now if I exit out of this and go to main.py, let's clear out of here. Let's go up to Let's load this on Unicorn. Okay, let's give in some values here. See if we can generate this with our new look. Come on, baby, show me the money. Ah, only compound 5 is showing up again. No. Yeah, we do have a lot of Indian representation here. Yeah, I started this from scratch, Leo. I build all my stuff from scratch, pretty much. Okay, so we're not getting we're only getting the 5th compound here, but the grouping is happening how we will like. Huh. So why are we only getting compound 5? I'm putting in distinct names, which is interesting. It should be okay from that standpoint. So, right, 1, 2, 3, 4, 5. They're all getting distinct names. Can you check the indents in the other file on line 72? Yeah. Self-thought compounds. Thank you, that's why. I can always rely on you guys. Got my back. There they are. Ha ha ha! Look at them traveling up there. So I'm gonna bring this back because they're pretty clustered now. I'm gonna bring this back to 100 frames, so it'll go up to 100% basically. Nice. So now we got our chroma plot converted over to our new format, rather than having. Right. So this 100 moves a lot faster. So what I could do is have my Y values increment from, instead of by 1. They increment by 0.5. Or I don't know, I like the faster movement, but it's just the faster they go, the more gap there is in the Y spacing here. Currently grinding Leet code like this is like another calming alternative to lo-fi hip-hop vid I can listen to. Yes, exactly, Leo. That's my whole intention. Is my whole goal here is that, like, you know, I'm going to be learning programming. I have a passion for it. I want to teach myself it. So if I'm going to be doing it, I might as well stream it. There's got to be some other people that are learning similar topics, similar ideas. You know, it doesn't have to be directly related, but the same kind of, you know, umbrella, right? And just by hearing it in the background, you'll become familiar, become refreshed. You know, you'll be kind of studying and reinforcing these concepts in the background while you're working on whatever you're doing. So you could be doing your homework. You know, I'm pretty good at holding myself accountable. I code every single day at 7 p.m. PST after work. I have a job. So for those that don't know, my name's Michael. I'm 26. I got a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I make biological controls every single day for 9 to 5. So I work 9 to 5, and then I come home afterwards and I stream every single day. So if you're having problems, holding yourself accountable and getting yourself to sit down and get to work, use this stream as an opportunity to, throw in the background. Either, you can pay attention and learn if you would like to learn what we're learning about that day or what I'm learning about, or you can just have it in the background just to hang out like we're like in the library together, back in college and whatnot. So you guys are awesome. Thanks so much for coming in and joining me. We just passed 1,900 subscribers. We're already at 1,905. We're pushing for 2K by the end of the week. I think we can do it. You guys are the best. Well, currently, this pretty much does what we want it to do. There's only one additional feature I want to add, and it's that I want to have this graph repopulate this image frame on this main screen, not load an additional tab. That's my goal. So how do you guys think we should go about doing that for the web dev out there? Who's out there got the web dev funnies? Ajax will do that for you, and we'll do it without refreshing the page. What is Ajax? Along with maybe jQuery. So can I do an event listener for this press and then call a prevent default, right, which will prevent the default of going, well, that will prevent the default of submitting the form, right? Well, is Ajax like another API thing I have to do? Because currently we got it all set up with Fast API. I don't want to have to like reconfig right now. I wanted to try to learn Fast API with this project. When did you start learning Python? I'm 2 months in. I'm so far behind. No, dude, you're only 2 months in. I don't put that pressure on yourself. I really think that by adding that pressure of like, oh, I got to learn this in some certain amount of time, really just, ruins the experience and makes it unenjoyable and will ultimately make you want to quit. So, from my experience, I really tried my best to make this something that I want to come sit down and do every single day because it's fun, because I enjoy hanging out with you guys, because I enjoy the process of learning and making something, not because I want to get money or because I think my stream's gonna make money. My stream makes pennies, like a cent a stream, like nothing. So it's not about that at the end of the day. It's about the learning and the fun. And like, I really think that like, modern day school and the pressures of testing has really put a damper on the treat and the privilege that we have, and especially for like if you're a United States citizen, to have the freedom of education. I can only talk about the United States citizens. If you unfortunately other people's circumstances, for gender rights and different circumstances, and I can't attest to those. But for my own circumstances, I have the ability, if I want to learn quantum mechanics and physics, if I had a desire to go learn about the ins and outs of the universe and space, I can spend the time and go do that. I have to make the personal choice to make that investment. Now, what was I saying? I just lost my train of thought completely. Now, Ajax is just a front-end thing that will send the request to your Fast API. There may be a way to do it in vanilla without something like Ajax, but not that I know of. It goes in your HTML page. Interesting. Because right now I'm calling read contents of this HTML page, and then I'm returning those contents. Yeah, I just completely lost that, Tim. What was I saying? I was saying, oh yeah, so I have the ability to, seek out this education. Like, it is a privilege. Like, in other parts of the world, maybe they don't have that. So it would just be, it's honestly really silly, unwise, ignorant of me not to take advantage of these opportunities I have in this life I'm, given. I mean, and what else would I be doing? I just be playing video games, or not that those are bad or anything, but at the end of the day, I can put 6 months into playing video games and be hard stuck silver. I could put 6 months into learning how to code and actually develop some sort of understanding of a programming language, and improve my synapse, fast sharpness and whatnot, and thinking and problem solving skills. So weigh the pros and cons however you would like. If you're hard stuck silver after a year of gaming, then maybe it's time to hang it up. Tim, I'm looking at you, Tim. No, I'm just kidding, man. Okay, let's go to the orb here. Let's ask. Okay, my friend, I am trying to now I am now ready to work on my HTML page for entering form data for the 5 compounds to generate a TLC plot. I would like this plot. I am able to generate the plot with my post, and the plot generates in a new tab. I would like the plot to generate and display within the current tab index.html in the place of the previous generation or img tag in HTML. How could I go about doing this? Please try to teach me, not tell me. Perfect, you're really close, and this is a great moment to learn how to tie HTML forms and fast API or any backend together smoothly. Let's break this down step by step. What you'll need. Your plot should display inside the same page, replacing the old plot if one exists. It should appear in an image tag or similar element without opening a new tab. This means you want to submit the form using JavaScript, Ajax, baby, to avoid reloading or redirecting. You want the backend to return an image, ideally a base 64 string or URL pointing to the image. You want to update the image tag source on the page using JavaScript. Let's explore what needs to happen. How is your current image returned? Are you returning a PNG file saved to disk, or are you returning the image directly using streaming response? I am converting the matplotlib to a byte.io and then using the, what did it say earlier? Streaming response to send it to return that buffer. with a media type of image/GIF. That's a strong setup. You're using the bytes IO and streaming response, which is great for sending dynamic images directly from memory without writing to disk. Now we just need to display that image in the same HTML page, not in a new tab. So returning it instead. Right now you're doing something like this, but this opens a new tab. Instead, to embed it, you'll need to encode the image in base 64, return it in a JSON response. On the front end, set an image tag's search or source to data image GIF base 64 your string. Update your fast API route to return base 64. So this is on submit. So this takes this is my current post. Are you learning, son? Yeah, I use ChatGPT similar to like I would like a TA. So I really try to tailor it to not show me code and try to, work through things with words and through, problems and whatnot. Similar to how you would ask a teacher questions or a TA questions or your friend questions. They're not gonna give you the answer and let you like cheat, but they're gonna coach you and help you along the way. And so yeah. To embed this plot. So without code, how can I do this? You want to let a user submit the data for 5 compounds, generate a teal supply on the background, display the results, same tab. Instead of submitting the form in the normal way, which reloads the page or opens a new tab, you'll use JavaScript to catch the form submission and send the data in the background. This is often done with the fetch or Ajax. Think of it like sending a message behind the scenes without leaving the room. So it wants us to. So on our form is type submit for the button. The form doesn't have an action though. Document get element form add event list or submit as prevent default. Okay, so if we go to our HTML here, we remove the action and method off of this form so they don't interact directly with our main. Instead, we're going to add an event listener within our script. So let's go down here. Do I not have a closing body tag? I guess not. So let's add in a script here. Okay. Does it go within our body? Yeah, I think so. Okay, so let's now do, we're gonna go document.get element by ID. We're gonna do the ID of, for our form, here. So ID equals to compounds form. So compounds form. We're going to do dot add event listener in the form of a submit type with a async function where we're going to take in the event it's saying, and then you call event.prevent default on the event, right? So then you go and make a const form data is equal to new. Okay, so a new form data via this, which is this form that we got by ID, const response, right, equals to await fetch the quote submit, right, given submit, right, given a method of post and a body of form data, right, and then that will close that. So then it's saying to do this. Nice, Winfred. How's it going, dude? How's your learning been? What you like about HTML? What you not like about it? So it wants us to go const data equals to await the response dot JSON document dot get element by ID chroma plot, right, dot source. We're going to override the source to equal this, whatever this is. Data image gif base64 data.image, and then that ends this here and closes our script tag. So now if I go exit out of this, let me go to main, Control C, L, unicorn. So let's do 5.9, 0.8, 0.7, 0.6, 0.5. So then what does my... Okay, so then if I have my main here, or my index.html has this now as my script. So then in my main, what should this look like? JSON response. Import. Base 64. Read the image into bytes. Can you show me how? Image buffer.getValue. So value base 64 image is equal to base 64 dot b 64 encode image bytes dot decode UTF. See, I don't know what these libraries are doing. And it wants me to return this here in JSON responses instead of the streaming responses. Base 64 IMG. So now if we let's exit here. Let's go here. UVcorn. Test 1, test 2. 0.9, 0.8, 0.7, 0.6, 0.5. Oh! Yes! Failed to load resource to server respond with the status of 404. Fave icon? What is fave icon? All right. Look at that. Woo! Yay! All right, I'm going to turn off this border. Why is it still here? What? Why do I still have the border? I honestly feel like I didn't do anything, Bailey. I feel like the almighty orb kind of did that last part for me. I didn't do any of that. I didn't know how. See, we got the element, we added event listener for the event, we prevented default. We got the form data and we made it new, we overrode each instance of this form data. What is form data? Is that an object in JavaScript? Why is my border still here though? Oh, it's not getting it. Now it's linking it. Why is there a border still? I don't think so. How to make fast API static refresh when I make CSS changes. Command Shift R. Oh, there you go. So why did it do that? All right, so this is what we have, everybody. Let me go ahead and make this over here a little bit. All right, so you have the ability. So we'll say compound 1. This has an RF, let's say 0.52. Compound 2, an RF of 0.21. Compound 3, 0.85. Compound 4, 0.41. Compound 5.3. Run. Woo! Yes, that's exactly what I wanted. So now It caches your pages to reload faster. Okay. Thanks, Bailey. All right, so now we have that being displayed on the web. Do you guys see anything that we should... So there's definitely stuff we have to add. So we need to add functionality for overriding these tick values as these names, right? When generating the plot. So that's something already. We need to generate the solvent and then the names here. Hey, Delta Star, welcome in. You can add some more JavaScript before the form data part if you want to change or show/hide an element for loading. Sorry, so when you say show or hide an element for HTML. Okay. I have a degree in human biology and chemistry. I graduated back in 2021, and I work as a formulation chemist, Winfred. I'm just learning how to code for fun and getting new skills here. Thank you for joining me. Let me go back up and read your messages earlier. You said, I'm learning so I can showcase my data science projects, and also gives me extra skills. Nice, dude. We're creating a thin layer chromatography simulator. So you can see on the black here, this is the solvent. As it travels up at 100% factor, these other compounds have a retention factor less than that of the solvent, and they will travel up at differing amounts or whatever. So yeah. So you could, for example, have some text saying loading that is hidden by default, and then has, yeah, that's a good idea. That's something I wanted, because currently there's nothing that says like, okay, we're generating a new simulation. So if I say run simulation here, it's like it's generating a new simulation, and there it goes. Now it has gotten it. So that's a good idea. So let's add that. That'll probably be the last thing we add for the evening here. This was a very, very productive stream. We did 3 Leet code problems and got our project to where it is right now. So huge stream, you guys. Huge stream. I don't want to give... So I'm giving... Compound section main. I'm giving a padding of 10%. There we go. Now that brings that up a little bit, but keeps our padding on the left and right. So then we'll give a padding top of, let's say, 3%. There we go. So it's a little bit less. 2%. There we go. So now you have a little bit less gap there. That looks good. So now we just need to fix that part right there on, make it resize. Okay, so let's add in that little JavaScript that Bailey suggested. I've been coding for about 10 months, Winfred, but I will specify that I've been coding and programming every single day for a minimum of 2 hours. Sometimes I go 3, most of the time I go 2.5, 3 hours. Sometimes I go 4, sometimes I go 5. On weekends I'll go 6, 7 sometimes. So I code and learn and teach myself every single day and compound the materials one after another. And I really try to reinforce the materials before I move on, so I'm ready to move on when I am ready. And so I'm not, going back and having to relearn old concepts or whatnot. No, I have them reinforced and ready to go for when I'm ready to move on. But I've been, and I've streamed every single session I've done so far. So I have over 500 hours of live coding streamed on this channel. And 500 hours, you might seem like, oh, that doesn't seem like a whole lot. But if you think about it, 2 hours every single day, that's like, 6 months worth of coding or something like that. So what is it? 6 months, though, 352 divided by 2 is 176 times 2. So even 6 months at 2 hours a day, that's still only 352. Wait, is there 352 days in a year? Yes? Yeah, I think so, yeah. Okay, that 352 divided by, 2, 6 months, so that's 176 days times 2 hours a day, that's 352 hours. So I've done, I've done 10 months so far. I've done, I'd say about 600 hours. So we'll say 12 times, we'll say 12 times, let's say 30 days on average, or sorry, 10 times 30. Sorry, 10 months, 30 days, 300 days times 2 hours a day, 600 hours. So I've done 600 hours so far, minimum, at least. 365, 356, 365, 365, sorry, divided by 2 times 2. So 365 hours, or in like 10 months, if I've done 10 months times 30 days a month on average, 300 times 2, 600 hours. Yeah, minimum. So, it might not seem like 500, because like people hear numbers nowadays, like subscribers or followers, and people are kind of numb to smaller or larger numbers. But 500 hours, 6 months, 2 hours every single day, 6 months, that's only 365 hours. And I put in so far over 600. So in 10 months. So, it's just, I've definitely been really grinding here. That's if you struggle to figure this part out, you could take some inspiration from how you were disabling the button last time I was watching, when you had the form to add and remove input boxes. Yes, that's a good, yes, I think I know, I think I can do it. Okay, so we're getting this, and we're looking for an add event listen. On the event listen, so let's add in a text here. Below the button, called label, or we'll say just, yeah, label. We'll say loading chroma plot. Please wait. Say loading chroma plot. We'll give this a ID equal to loading label. Okay. So we're gonna go const loading label is equal to document dot get element by ID via the ID of loading label. Right? Okay, we're gonna get this. So by default, we're gonna get this element by ID. By default, loading label dot there's remove what's the, I know, Bailey, you're probably like, you scream it at me here. What's the, so there's the remove. is disabled. Set attribute. Okay, so set attribute, but I don't want to set an attribute of this. So Bailey, how can we make this disappear? What do we have to apply to the label here to initially hide it and then show it when we have this press of a button and then hide upon release? So here we would say loading label dot something, and here we would say loading label dot something. So say if we were to have a label appear and disappear when running an add event listener for a form, what show me JavaScript example for element dot style. Dot display. False. None. Okay, a block or flex. Is it quote? It's text. So let me go here. Let me just set this by default then. So when they press the button, you're gonna display it as flex, and then when you're gonna set this back to none. So I shift command R. I do test. Point 2, point 3, point 4, point 5, point 6. Run. I get loading chroma plot. And there it is. So I could just give it a permanent status rather than display none. So this is what I'll do, is I'll display flex from the jump, and then what we'll do is rather than displaying none, we'll display it the entire time. We'll just say style dot text content equals to quote status loading chroma plot, and then we'll say we'll take this, put it here, say status finished. So then our status is going to say default none by default. So now if I go test 1, test 2, test 3, test 4, test 5, point 8, point 5, point 6, oh shoot, point 8, point 3, point 2, point 6, point 7. I run, I get loading chroma plot, and then finished. Woo! Woo! Look at that. Yeah, this looks awesome. This looks so good. How do you guys like it? Do you guys like it so far? Look at that. That's so cool. Thank you so much for your help, Bailey and Winfred. Look at that. So our next thing that we'll do tomorrow is that we need to have these tick marks be overridden as the compound names that they provided. And we also need, right, because currently if this errors out, right, it says finished. So if this errors out, I would like to detect this error on this post request to the submit and return a stock default image, right, to replace here, and then also have this status be updated as error, right? So if they input. So what also can't happen is they cannot put in duplicate values for names. If they put in duplicate values for names, it will break, because we're using a hash or a map, and maps can't have duplicate key values. So if I run this simulation, right, run it, I'm loading the chroma plot. I'll generate a plot, but I won't generate any values because it has nothing to update here. It's overriding itself every single time. So that's why that's happening. So I need to have some data validation to not allow for duplicates on the names, and then B, detect when I get an error 22 from down here, and fix those. Like, so here if I go run, I get this error here with no image being displayed, and I still have status is finished when it's not correct. So if I change this to 2, this is 3, 4, 5.5, right, and then I run this, I get loading chroma plot. And then there they are. And now we need to allow for also like a save feature. So a button over on the right here that allow them to save this GIF to their hard drive is something else that we want to add. I've been learning Python for about 10 months now, Seiko. Thanks for coming in, dude, and leaving a comment. I appreciate you so much for joining me here. Alright, you guys, we've been streaming for 3 hours and 13 minutes. This was very successful. We completed 3 Leet code problems today. Or no, not 3, 2 Leet code problems today. 2. We did 2 Leet code problems today, so nice, very nice. They both involved kind of sets or maps, so it's pretty easy to complete those ones. We did those ones in the first hour, and then for the back 2 hours, we worked on our project here and successfully converted over our plot from our old plot to our new plot, where we're no longer using these streak values and we're just kind of doing these clumpings. And then we incorporated Bailey's idea, which was really good, for managing these buffer values. Rather than using a square root to compute the buffer across the x-axis, we're using just a solid value and then just reducing it by that to keep these clusters pretty contained, as you can see here. And then we added in that finalization, that ending buffer, so that when it ends at 100%, it will finalize and kind of freeze there just like that. It'll freeze there for about 20 frames and then finish the GIF. Yeah, I study every single day around 7 p.m. PST after my 9-to-5 job as a formulation chemist. I have a degree in human biology and a minor in chemistry. Another thing that could be cool if you care is have it ease in at the start. All 5, 6 dots for each component pop up. Could be good to do it one at a time until all 6 are there. Yeah, that's currently something I don't really know why it's doing that. It's kind of... Oh, I get what you're saying. It's all 5 dots are just popping up right there at the very start. So on 0, you just populate the 1 dot, and then you go up to the 10, and then that cluster travels together. Could help smooth it out, like an ease in. You start, so I see you, it's spawning all 10 right there, all 10, and then moving forward. So instead of spawning all 10 and then going up, just spawn the single dot, have it go up and do 10 frames and collect 10 frames worth of data, and then transact those forward from there. That's a good idea too. We'll have to think about how to do that next time. All right, you guys, and so I will be opening this up to like an open source, or I'll push it to GitHub when I have something more finalized, like a kind of what I do is I'll work on the project, I'll get it to something I'm happy with, that I had the goals in mind for, and then I'll release it so everybody can work on it together and we can improve it, just like I did for the Small Business Manager. So if you guys want to participate in an open source project, currently I have the Small Business Manager open and available for you guys to contribute to, and really provide a lot of input. Funny enough, my shirt's been inside out this whole time. What the heck? Inside Out, there's the, come on. Inside Out this whole time? Embarrassing. All right, you guys, I'm going to head out. I'll see you guys tomorrow around 7 p.m. PST after I get off work. I'll see you guys tomorrow. Thanks so much for joining me. We completed a couple of Leet code problems. Really got some great work on our project here, getting the front end all linked up to the back end and showing our graphs here in place, which is really awesome. And so let's go ahead and push this up to GitHub, and yeah. We'll say I need to commit more often. I didn't commit earlier, and I'm kind of merging a lot of changes here. Oh shoot, not merging, but I'm committing a lot of changes. So I need an overarching message here. Fix. We'll say compound clustering. Front end visualization, and we did, yeah, that's it. Fix compound clustering and front end visualization. And front end plot generation. Python's one of the easiest, easy to read. Yeah. No, I thought Python, I mean, it was just difficult. The hardest part about learning this is just kind of, it's like, honestly, like, it's a similar, like, way of thinking about like your first couple days in high school Spanish is what I kind of related it to. When you walk in, everyone's talking in Spanish or in Japanese or whatever class you're taking in high school, a secondary language, and you're like, what is going on? Like, that's how it feels for the first 2-3 weeks. It's a struggle. You don't know what's going on. It's just getting exposure, and then it really starts to click. It's really similar to learning kind of other languages in terms of like the syntax and the understanding of how things go together. But once you kind of get the general flow of like loops and variables and everything like that, it all is consistent across. It's just you have to add semicolons or different ways you define functions or whatnot, and that stuff's kind of just trivial. So it is true that what they say is that once you kind of know one really, really well, is you can really expand out. So that was my goal, is to really try to learn Python to the max with Python crash course, data structures and algorithms in Python, fluent Python. These are all books that you can find in my Discord link down below that I've read live on stream or in reading live on stream. Anyways, whoever just unsubbed, you suck. Anyways, I'll see you guys later. Thank you so much for being here.